So in one of our exams, we got this question: write an algorithm in Python that sorts an input array by calling a subroutine. Square root sort AK, it sorts the subarray A from k to k plus square root of n minus 1, given an arbitrary integer k between 0 and n minus square root of n. Assume that this subroutine is given to you as a black box. To simplify the problem, assume that square root of n is also an integer. Your algorithm is only allowed to inspect or modify the input array by calling square root sort. Okay. In particular, algorithm must not directly compare, move, or copy elements. So the usual methods, like you know, like all the methods, basically merging and binary search and all those things. Well, those are not going to work for individual elements. Okay, the running time of your algorithm will be judged on the number of times you call the subroutine square root sort. How many times does your algorithm call square root sort in the worst case? So I was not able to solve this problem, and I kept thinking for half an hour on what's the best solution. The main problem with this question is that they didn't give us under what should be your minimal complexity. So when I asked the professor what should be the expected answer, he said that it's order of n. And then when I was talking to some other people, well, they said that yeah, they got order of n, and the way that they got it was they are basically uh, bubble sorting square root of n upon 2 elements. So you got this array of n elements. What you will first do is you will divide this into 2 square root of n times square root of n upon 2. So square root of n upon 2 elements, those like the row vectors basically of square root of n upon 2 elements, and 2 square root of n of these row vectors. So now this array has been converted to something like this, a bunch of arrays, right? All of length square root of n upon 2. Now we can square root sort any square root of n elements. So if I just square root sort the first square root of n elements, that is the first two smaller arrays combined, then what will basically happen is that after I sort this, you will get once again square root of n elements, and you can split that into two arrays once again. This array will contain all the bigger elements, so it will contain the maximum, like the largest square root of n upon 2 elements from this whole array, right? So we can say for sure that every element over here it's less than this, right? And then you will just you will just square root sort the next two arrays, and now you know that every element over here, this complete square root of n block, that is less than the square root of n upon 2 elements, right? And you will just keep on going like that. So you will have to do 2 square root of n minus 1 iterations, and you are okay, but before that, wait, yeah, right, it's like 2 square root of n minus 1 iterations, and then and then eventually gonna get like this. So this has bubbled up. Basically all of the maximum elements have bubbled up, and in the increasing order only, because whenever you sort, these last arrays always have elements in the increasing order, and so on. And now you have these n arrays which are sorted and which are sorted and have, what should I say, and are 2 square root of n minus 1 in number. Yeah, I think so. Okay, and then you can just repeat this sequence. So next time you will just do, for all of these, which is like 2 square root of n minus 2, and then just keep on going. Eventually we'll hit 1, right? So this will be, since this isn't just like sum of an AP, something like that, this will just be this number 2 square root of n minus 1, that times of this plus 1, which is just 2 square root of n, and that upon 2, which is what, it's just, so that 2 cancels, it's just 2n minus 1, it seems. Yeah, that looks like the thing, right? So basically its order is n, so this is order n, and that was the answer, that is order n. And I'm not satisfied with this answer. I mean, I came up with all kinds of crazy things that could be done with this, and none of them look correct. So like there's one thing that I did where I would just form these column vectors of square root of n length or square root of n upon 2 length or whatever. I would form 2 square root of n of these column vectors, and then what I would do is like I would just sort these two, and what that would do is like it will have this kind of a flow after that. So yeah, this will be bigger than this element and so on. So like say I have connected such column vectors till like the case column vector, and then I want to connect the next column vector to this, right? Like I've magically somehow done this. Then how would I be distributing all the elements from this vector to like be put into this vector, into this, how do you even call this, snake kind of thing? So like I'm thinking of these first elements as check marks. So if you know that some element is bigger than this first element, then you know it's gonna lie in this array, that it's gonna be inserted in that array. So first you will just check in these indices, and then you will just put that in this thing. Basically that's what I'm thinking. um, and the problem with that is it could lie anywhere in the array, which is not what we want, right? Yeah, we definitely don't want that. Yeah, so this is kind of problematic, really. So I guess order of n is the best that you can get. I mean, people are getting all kinds of complexities, some going to square root of n, but then their solutions are wrong. The same as me. Solution is wrong. Um, yeah, so it seems that order n is the best thing. If any of you get like, I don't know, some solution which is of less complexity, make a detailed video on that and send me the video, because I really want to see if that is actually the best complexity. I mean, the professor said it's the best complexity, so I guess that is the thing. Fine. I'll see you guys in the next video.